Hi, hello, this is your Aki sir. In this class, we'll go with the preparations of acetone. Acetone is CH3COCH3, C double bond O CH3. So you can say it is a first ketone, carbonyl group. Both sides we are having carbon, so it is first ketone you can say. So preparation methods. You can prepare from oxidation of alcohols. Here you see how it is going to be. CH3, CHOH and here CH3 is there. You can see this is a secondary alcohol. Isopropyl alcohol like this. CH3, and from here one hydrogen and from here one hydrogen gone. These two will be removed so that you are getting the CH3, C double bond O CH3. So this you can say mild oxidation. For this purpose, the reagents you can use are PCC or PDC. When you are using PCC and PDC, the medium must be CH2Cl2 or dilute K2Cr2O7 also you can use. As I always say, my favorite type, Fenton's reagent FeSO4H2O2, or you can use chlorine or bromine or iodine. These are also okay. So this is mild oxidation of alcohols into ketones, but remember it must be secondary alcohol. Secondary alcohol can be converted to ketone. In this case, if you are using primary alcohol, that will be converted to aldehyde. Check carefully. Next, dehydrogenation of alcohols. It is also very similar. See here what I am going to use: copper or silver at 300 degrees Celsius. This is again isopropyl alcohol. Isopropyl alcohol converted to ketone. Same thing, na? Here also hydrogen is going to be removed. Okay. Copper and silver. The specialty of this reaction is here tertiary alcohol is also possible if you are using tertiary alcohol, but tertiary alcohol will give you alkenes. Dehydrogenation means removal of hydrogen. Here you are removing hydrogen, but in this case you are removing water molecule. But this is also done by copper or silver at 300 degrees Celsius. This is a tertiary alcohol converted to alkene, but our preparation is about acetone. So isopropyl alcohol is converted to acetone by using copper or silver at 300 degrees Celsius. Next, dry distillation. Heating. Distillation is nothing but heating, simple heating. This compound is CH3COO taken twice calcium. This is called calcium acetate. How it is going to be? CH3 C double bond O calcium O C double bond O CH3. Fine. What I am doing is here heating. On heating, it goes like this: CaCO3 calcium, carbon, 3 oxygen, CaCO3 out. So what is remaining here? CH3COCH3. Dry distillation of calcium acetate will give you acetone. Dry distillation of calcium acetate will give you acetone. Here one more question you can see: CaHCOO taken twice. If it is taken on heating, it gives formaldehyde. Remember, this is again very important. But if you are taking mixture of these two, calcium formate and calcium acetate, both if you take CH3CHO. These preparations are already there in the previous class, preparation of aldehydes. If you want, you can check. Here calcium acetate on heating gives you acetone. Fine. Next, from propine, this is one very interesting reaction. Propine is this one, CH3, C triple bond CH. When you are adding water, here Markovnikov addition takes place. Markovnikov addition means H plus and OH minus. If you take simple sense, I am saying hydrogen should be added here, OH minus should be added here. Okay, now this is actually nucleophilic addition reaction, OH, which undergoes a change called tautomerism. Remember one very interesting question, CH triple bond CH on reaction with water gives you aldehyde, that is CH3CH. Rest all alkynes, ketones. Only acetylene gives you aldehyde, remaining all alkynes will give you ketones only. So here Markovnikov addition of water takes place, that is H will be added here, OH will be added here. You can check. Then after tautomerism means this bond is shifted here, this hydrogen is coming here. Simple sense. This is not the mechanism. This is not the mechanism, beta. Just for understanding, I am saying this bond is moving here, it is coming here. If you want exact mechanism, follow my class tautomerism. It is there in GOC. You can check. Hydrolysis of geminal dihalides. Geminal means on same carbon. Okay. But these geminals must be, that means these two carbons must be on the middle carbon. For example, chlorine and chlorine. And when you are going for hydrolysis, it is like this. This compound is nothing but this one. Simple sense I am showing you here. One carbon cannot hold two OH groups. So this OH and this H gone. So this is double bond. Simple, very simple. If you are having two chlorines here, for example, this is also geminal, but this is terminal geminal. This is internal geminal. Terminal geminal, if you take, same thing, two OH groups, unstable, it will be converted to aldehyde. So terminal, if you take, aldehydes are formed. Internal, if you take, ketones are formed. So you must be careful. So you can prepare from the geminal dihalides both aldehydes and ketones. And here we are going with ketone. Our intention is to prepare the acetone. Check this carefully. If you want notes, just go with this again. You will be getting easily. Next, Walker's method. This is again very interesting method. In Walker's method, see, this is alkene. PD here in +2 oxidation state. Here PD is in 0 oxidation state. That means PD is undergoing reduction. And our alkene is undergoing oxidation. Okay, now PD and 2 chlorines, 2 hydrogens, 2 HCl out. This oxygen is added here. Ketone. Walker's method, very special. From carboxylic acids, you can see this one. This is very similar to the earlier dry distillation type. Here you see MnO, this oxygen should be become MnO. Manganese oxide at 300 degrees Celsius, same thing. CH3, C double bond OH, CH3, C double bond OH. For easy understanding purpose, I am writing like this. It's not the mechanism. Water out, CO2 out. So CH3, COCH3, you are getting the ketone. Acetic acid gives you acetone in presence of manganese oxide at 300 degrees Celsius. So this is from carboxylic acids. From acyl chlorides, this is again very interesting. Actually, what happens here is we are going to prepare R2CD, dialkyl cadmium. How to prepare dialkyl cadmium? It's very simple. From RMGX. RMGX is Grignard reagent. When Grignard reagent is treated with CdCl2, it forms dialkyl cadmium R2CD. This R2CD when treated with RCOCl, RCO, this R is coming here, this chlorine is out. For balancing purpose, we are taking 2. From Grignard reagent, dialkyl cadmium. Dialkyl cadmium when treated with acid halides will be giving you ketones, and CdCl2 is out. Nitriles. Nitriles means cyanide. Okay. Treating a spelling mistake, sorry. Nitrile with a Grignard reagent followed by hydrolysis yields a ketone. Okay. See this reaction. CH3, CH2, C triple bond N is there. Na? The C6H5 MgBr always will be having negative charge and plus charge. This negative charge on carbon. This will be added here. This plus charge will be added here. So this MgBr is like this. Now you can say it is like this. If you don't want to show here, you can show like this. Then on hydrolysis, this is oxygen, this is out. C6H5, CH3CH2, that is C2H5, C6H5, that is C6H5, this is C double bond O, C double bond. See the complete reaction. Cyanide treated with the Grignard reagent, you will be getting this one. On hydrolysis, you are getting this one. From nitriles, you can prepare. Last one, very special reaction is Friedel-Crafts acylation. It is benzene when treated with CH3COCl, for example. You will be getting here COCH3. Here AR or R is written. AR means phenyl type, R means methyl ethyl type. This is anhydrous AlCl3. Okay, so you are getting there. This compound is, if it is not clear, I can show you. In place of this, you can write R also. Friedel-Crafts reaction, spelling mistake, Friedel Crafts acylation. I kept a video related to 10 most common spelling mistakes, and this is not my fault, this is my computer operator fault. Of course, I should take care of this. I'll check, no problem. Thank you all. So these are the important methods of preparation of ketones. Just go with this. If any doubts, send me the questions. I will try to give you the answers. Thank you.